It's not until the last subsection of this textbook section that your textbook starts to talk about using matrices to represent a system of linear equations. So in the textbook, they go to a lot of length to describe what a matrix is, what different types of matrices are, what some of the features of special kinds of matrices are, and so on, before they tell you how it can be used. I described how to use a matrix or how we often use a matrix as a sort of a shorthand for a system of linear equations. I described that in the first video for this section, and their textbook is just now talking about it in the very last section, subsection of the section. So I'm going to go ahead and address it here so that it's in line with the textbook, but I may not spend a lot of time on it. One thing I can do with this subsection, since we didn't do it earlier, is I can take a step forward and look at using a matrix to represent a system of linear equations that's bigger than the one I did in the earlier subsection. So here what I have is a list of 3 equations, and I have 3 unknowns, 3 variables, not just x and y, but x, y, and z. And to make a matrix out of this, I'm just going to take the variables out, leave just the coefficients, and that means that the first row of my matrix is going to be 3, 2, -4, and then 12, because this is an augmented matrix. That's a 1 in front of each of those, so that's going to be a 1, -1, 1, and 0. And then I have a 2, a 5, a 4, and a 9. So turning a system of linear equations into a matrix just entails kind of copying down the coefficients in the same order that they appear in the system. It's important that the coefficients for each variable line up. In other words, if I had, I'll do a smaller one here, 2x minus y equals 1 and 3y plus 2x equals 0, just copying that down, 2, -1, 1, 3, 2, 0, that would be problematic, because what I'm saying here is these are my x's, these are my y's, and those are my constants. And that's not true. This is an x, so it's in the wrong column. So what I really should do is rewrite this system first. 2x minus y equals 1, and then 2x plus 3y equals 0, and then I can transform it into a matrix 2, -1, 1, and 2, 3, 0. Now it's correctly transformed into a matrix. It's an augmented matrix because we have a constant term, so I could put this line down the middle here. Sometimes instead of a line, you see a dotted line. Depends on the textbook, it depends on who's writing the problem. But that is the primary way in which we're going to be using matrices. So that was a nice short one because we've actually already addressed most of this, the ideas you see here. But that's going to do it for this video. That's the end of this section. In the next section, we're going to be looking at some of the things that you can do to matrices. Not so much what you can do with them yet, but what you can do to them, how you can manipulate them. See you over there.